So we're told this is a kite. Of course, the markings would show us that also. Which markings am I talking about? Well, maybe they don't say anything about them in this case. What should be true about those diagonals if it's a kite? Okay, so maybe we could add those markings to say that those two segments, WQ and YQ, are congruent because the long diagonal bisects the short one. Good? What else is true about them, about those diagonals? Yeah. Yeah, they are perpendicular, and like Parker said, we have 4 right triangles. Good. And then the markings I was talking about are these ones. So it's showing that 2 consecutive sides are congruent. Same here, but opposite sides are not congruent, therefore it's a kite. The reason we have to say opposite sides are not congruent is because then we start getting into parallelograms instead. Like I told you yesterday, we'll learn that next semester. Anyway, get rid of those for a second. Actually, I'm going to leave those on there. I think we can see around it. So measure of angle XQY is that angle right there, which I just marked. And what is it? 90 degrees, good. Measure of angle YZQ is that angle right there. And for that one, yeah, maybe zoom in on this triangle. We know that that angle is 90 right there. So I'm just redrawing this triangle. And can I copy 56 right there from this 56? Are those 2 angles congruent? Yeah. Okay, and then we just do our usual triangle calculation. We'll get 34 degrees. And then WY, so the whole length of that diagonal. Well, it shows us that one side, YQ, is 12. So what can we do with the 12? Yep, just copy and paste it so we can just double that and get 24. Okay, so kind of a light problem for a starter today just to get us back thinking about kites a little bit. Today we're going to start working on equations of parallel and hopefully perpendicular lines. So on your notes yesterday, go ahead and pull those out if you don't have it. I put this under the section coordinate proofs, but we will be writing equations as well, which isn't part of a coordinate proof, but it's good review. Anyway, we learned yesterday that parallel lines have the same slope. And so, for proof's sake, we find the slope of all the sides, put the slope formula back in there, and then reduce, simplify, and then use that to compare to see if they're the same. In terms of writing equations, I'm curious what you remember about that from algebra. So let's put an example in your notes. And we have a good set of examples going already. Okay. So I wrote equations out to the side there just to remind you. So it's quick reference. What do you remember about writing equations? This is for lines, so they're linear. What do you remember about that from algebra? It's kind of a big focus in algebra. Well, let me remind you of a couple things. Remember this form? Okay, most people call it y equals mx plus b. The name of it is slope-intercept. Which of the letters is the slope? Yeah. And then B is the what? The y-intercept, okay? All right, so we might have to come back and do an example in a second after some notes. How about this form? Anybody familiar with it? It's called point slope form. And honestly, I like it the best for a lot of things in math, but it gets less attention than slope intercept form. And I'm not sure why. I tend to teach this method and then convert it to slope intercept, and it's because it's usually easier to write. Actually, almost always easier to write it this way. So maybe let's come back to the example because I can tell we're a little bit weak on this. That's okay. We'll take some notes under this needed formulas section on the equation stuff, and then we'll come back and do that. So for lines, equations of lines. By the way, this will be on your final as well, so make sure you stop me if you have any questions. First one we'll write is y equals mx plus b. And that's called slope-intercept form. And the name tells you what it tells you, meaning it tells you the slope and it tells you the y-intercept right away. So in terms of labeling, m equals slope, and b is the y-intercept. What is a y-intercept? Yeah, it's where it crosses the y-axis. So it's, Parker, yes to your thing if it's the y-axis you're talking about. Okay, so in fact, let's write that on there. So it's where the line crosses the y-axis. And then here's the big deal with that. It's where x equals 0. Because every coordinate on the y-axis has an x coordinate, every point, on the y-axis has an x coordinate of 0. So you can often just set x equal to 0 and solve for the y-intercept. Okay. The other form, again, my favorite form, is y minus y1 equals mx minus x1. And this is called point slope. And the reason why is because this form shows you a point on the line and the slope. So x1, y1 is a point on the line. M is the slope. So hopefully you can see why these are named the way they are. Sometimes things in math don't really seem to have a logical name, but these do. Okay. If I said write an equation in slope-intercept form, what would you need to find in order to do that? The slope and the y-intercept, right? Okay, which the slope is the same for both of these, but this is why I like the second one better usually. You will always have a point on the line, otherwise you wouldn't be able to write the equation. You won't always be given the y-intercept, and so you'll have to solve for it, which can be a pain, a little bit. But you'll always have a point. So if you have to find the slope in both cases, why don't you use this form and just plug the point in, okay? And then if you want, from there you can convert it to slope-intercept form, okay? So with that brief review, let's go back to the example. This is just going to be an example of writing an equation, and then we'll start talking about parallel and perpendicular equations. We haven't actually taken notes on the perpendicular yet, so we'll see if we get to that today. Okay. Here's your prompt. Write the equation of a line through, and I'm just going to give you 2 points. Okay, so we have 2 points on the line. You could graph this if you wanted, like go plot it on the graph. You don't need to for this. Okay, step 1. You know what, before we do that, I want you to say in both forms. And so what I mean by that is point slope and slope intercept. At least the way I teach, and you can do it differently if you have learned it differently, but I teach you to write it in point slope first, because then you have an equation right away. And honestly, like in my calculus class, we don't really deal with slope-intercept form at all. And so if we're doing that level of math without slope-intercept, I feel like we're good if we can do it here too, right? Just work with point slope. The thing is, sometimes during testing, you'll still run into slope-intercept form. So your first step is to find the slope. And for that, remember it's y2 minus y1 over x2 minus x1. Basically, all we're doing is seeing how much y changed and how much x changed. So we go do that. M equals, it's sometimes, before I do that, it's sometimes helpful for students to label the points with the x's and the y's so that you don't get mixed up when you plug in. Here's what I mean. Like label this x1, y1, and x2, y2. Because then when you go to plug it in, it's super straightforward. Okay, so y2 minus y1 over x2 minus x1. Okay, so y2 is negative 10 minus 5. That's y1. And then x2 is negative 3 minus x1, which is negative 2, or positive 2, excuse me. Okay, this becomes negative 15 over negative 5. What is negative 15 divided by negative 5? That's just positive 3. Okay, so my slope is positive 3. Okay, step 2. Plug in the slope and x1, y1 to point slope. Literally, you're just substituting stuff in there. So here's how that looks. It looks like y minus, and I'm going to leave that in just a second. I'll plug it in. And over here, x minus. Okay. What is y1? Based on what I've labeled, what is y1? It's 5. So y minus 5. And then what is m? 3. And then x1? 2. Okay? So I just plugged in those three things. I stuck them in place of what they were labeled x1, y1, and m. That is an equation of a line. If you went to Desmos and plugged that in, it would graph the line. In fact, I'm going to do that just to show you. Desmos. So y minus 5 and equals 3 times x minus 2 parentheses. So there's a line right there. Okay? It's a line. We don't have to have it in points or in slope-intercept form. You could stop there. For my sake, if I say write an equation of a line, you can stop there and I'm perfectly happy. Okay, but let's go ahead and convert it to point slope form. Sorry, slope-intercept. And I'm going to say if needed, because, like I said, you don't necessarily need to do that. All right, for this, the job is pretty simple. Here's the job. Just get rid of... seriously, get rid of parentheses. By itself. Okay, let's get rid of parentheses. How do we do that? Just distribute, yep. Okay, so it's going to look like whoop, right? 3x minus 6. Just subtract, multiply the 3 by both things. Now, how do we get y by itself? Add 5. Good job. Add 5 to both sides. And we'll get y equals 3x minus 1. Okay. So now we have it in slope-intercept form. We know the y-intercept. What is the y-intercept? -1. So if we went and graphed, and in fact, let me show you back on Desmos. If I type in y equals 3x minus 1, do you see how it's the exact same line? Like turn it on, turn it off, right? On, off, etc. It's the exact same line. And if we zoom in, we can see our y-intercept right there. In fact, let me see if I can highlight that. Right there is -1. Okay? That's, to me, the best and most efficient way to write an equation of a line, since we will always be given at least 1 point. Sometimes you're given the slope, and a point. Sometimes you're just given 2 points. Sometimes you're given a whole table of values, but you will always be given at least 1 point. And so use the slope and stick the point in, and you have an equation. And then if you want, you can convert it to, or if you're asked to, convert it to the other form that's easy to do. Get rid of parentheses and add whatever is over there, add it or subtract it, and you're done. Okay, any questions on that? Okay, so that's kind of background. Our job is going to be to write equations of parallel and perpendicular lines, okay? So if I said write an equation of a line parallel to that, well, we learned yesterday that the slope has to be the same. But if I have the same y-intercept, it's the exact same line. So it wouldn't be parallel anymore, it would just be the same line. So what has to change from, let's use this bottom one, from 3x minus 1 for the line to be parallel? Yeah, we just need a different y-intercept. So it could say 3x minus 2, or 3x plus 10, or any other number besides negative 1, and that will be parallel to our line. Okay, so back here again, if I change this to, let's say minus 5, well, that's plus 5. 3x minus 5, okay? So those two lines are clearly parallel. If I change it to 3x plus 3, again, it's parallel. So same slope, but we have to change the y-intercept, otherwise we're landing right on top of the same line, okay? Sometimes that second line will have a point that we're required to go through, and then we just plug it in, okay? So I'm going to continue this example. That way we don't have to start over. And let's do a parallel one. I think we'll squeeze 2 into this box. So first we'll do the parallel and then the perpendicular. Write the equation for a line. And like I said, we'll do 2. So part A is going to be parallel. And we need a point to go through. So parallel through, how about negative 2, 5. Well, we know the slope. What is the slope? Has to be 3, right? Okay, so first step, underline that. Step 1, find the slope. Same thing as we did before. Only this time, it has to be the same slope. So that was 3, okay? We figured out 3 before, that's why I said continue this example. So m equals 3. Step 2, plug in the slope and the given point. Plug in the slope and the given point. Okay, but we're going to use point slope form. So y minus y1 equals m times x minus x1 in parentheses. Okay, we're plugging in y1, we're plugging in m, and we're plugging in x1. Now, the given point, we don't really have much option, right? It's just negative 2 and 5. So if we go rewrite this, come on, write it. Okay, and what is y1? 5. What is m? 3. What is x1? -2. Now, this is something to be careful with. The pink minus sign is part of point slope form right there. It's always going to say x minus. And then I wrote -2 because that was the point. But what is minus minus? Yeah, it's plus. So you probably would see this as x plus 2. Okay, but it's the same as minus minus. So if we clean this up, then it would say y minus 5 equals 3 times x plus 2. Now that's parallel. It's not necessarily in your favorite form, but it's parallel. In fact, if I go put it in there, so y minus 5 equals 3 times x plus 2. And you can see that green line is clearly parallel to the first one. Okay, so we're done. Plug in your slope and a point. It's so nice. Like, I don't know why we don't focus more on this in Algebra 1. I'm trying to teach my Algebra 1 students this more so. Okay, and then again, if we're asked in slope-intercept form, sometimes we're forced to do it that way. What do? Well, we get rid of parentheses and get y by itself. Okay? So what does that look like here? Well, we're just going to go multiply by 3. And we'll get 3x plus 6. And then we add 5 to both sides. And we'll end up with 3x plus 11. Also a valid equation. Notice our y-intercept changed. It was -1, now it's 11. Obviously, it's not the same. Okay, that's parallel. It's the easier of the two for the most part. So use the same slope, plug in the point, you're done. Unless you have to convert it. Any questions on that? Okay. Let me give you a chance to just try it on your own. So zoom out. I'm going to try this. Whoa, why am I clear up there? Or clear down there, rather. Patient. Okay. What points should we go through? How about something like 1, 2? All right. Not sure how it got vine from line, but that's okay. All right, give it a shot. All right. Here's your first one. So I labeled the 2 points and just x1, y1, x2, y2. Make sure that you don't mix up, like this is not x, x, y, y. Sometimes students mess that up. So it's always x, y, x, y. Okay, I wrote the slope formula and then plugged in numbers reduced to get 1/3 for the slope. Okay, number 2, step 2, plugging it in point slope form. So we just plug in 6 and -2 from the point, and then our slope was 1/3. And then I just changed the minus to plus. So this is a valid equation for that line. Totally fine, like totally normal. Just to review converting, so I distributed the 1/3 and got 1/3 x, and then 2 times a third is 2/3. And then added 6, so it's 1/3 x plus, and I left it as a mixed number, which I don't usually like, but if I said graph this, it would be easy to do. So 6 and 2/3 is part way up from 7. Okay, and then the second one, parallel. We know that has to have the same slope. So step 1, m is the same. M equals 1/3, same slope. But now we're going through a different point. So now we're going through point 1, 2. So we plug in, and we'll get y minus 2 equals 1/3 times x minus 1. And that is our parallel equation. Totally fine to leave it like that. But if we wanted to convert, or if we're told we have to, we'll get y minus 2 equals 1/3 x minus 1/3. And then add your 2. And we'll get y equals 1/3 x, and then plus 1 1/3 if you want to leave it like that. Okay, how'd you do on those? Okay, I'm going to hand you some practice. Remember, tomorrow we have NWEA, so we will not be doing this then. But you need to bring a charged Chromebook. Don't forget that. I'll send out a reminder. On this one, just do 1 through 4. 1 through 4. So 1, 2, 3, 4. I guess I'll see you tomorrow. NWEA. Have a good day, guys.